Right, good morning. This is the next video, and this is on learning curves. Now, let's discuss this a little. I actually quite enjoyed looking at this and working with this. And let's really discuss the origin of what's going on here. Again, like the high-low method, we were trying to find, with the high-low method, the question is, what was the point of the high-low method? We were sort of saying, we know what happens at 200 units, we know what happens at 500 units, what happens at 400 units. We don't know that, but we know this, can we find this? And there's nothing so different here, where we're given what happens at certain units, and we need to find out what happens at other units. But in the same way, the only way we could find out what happened at 400 units, we needed a kind of common curve or a common equation to help us, or standard equation, so to speak, that we could then go back and plug figures in, and then find what was happening at 400 units. And the same thing is happening here. But this time we're talking about something slightly different. So here we're trying to find variable cost. Here, in a way, we're trying to find we're ultimately trying to find how many units we should produce based on the idea that costs actually decrease, so to speak, with more units that we make. But just how they decrease is what we're almost trying to find out. So that's what's going on here with this idea of with learning curves. So what are learning curves? So what we're saying here is that as social scientists, as observers, we found out there is a tendency for labor time per unit to reduce in time. So the more, and I guess that comes, you can naturally accept that the more time you spend working on, so the less time you spend. But the question is, how less? How much less? And that's what this whole thing is really sort of saying. Like I say, it's really saying that if more units are produced, work has become more familiar and with the task, and you get quicker. And this is an example here. It says that aircraft production during World War II review reveals, that the rate of improvement was so regular it could be reduced to a formula, and the labor hours required to be predicted with a high degree of accuracy from what's referred to as a learning curve. Now, again, of course, everybody doesn't know what's happening the first time something happens, and as you repeat it, you become more efficient, and the labor cost per unit declines. Now, there is this argument. Mr. Wright somewhere believes, or the argument is, that we don't, of course, the difference is that the percentages, it just says a fixed, it'll be different for different organizations. But here's the thing, here is the key issue that you need to be comfortable with. As cumulative output doubles, it's all about accumulation and averages. And this is no different from the demand curve. It's the same idea. As cumulative output doubles, so if something goes from 1 to 2, 2 to 4, 4 to 8, 8 to 16, that's what we're talking about here. As this doubles, the cumulative average time, so for example, if this took 10 minutes, then we're saying that this will, the cumulative average time, so this will take, for example, 8 minutes, but the total time, of course, is 18 minutes, but the average time is 9 minutes. This is important. It took 10 minutes to make this. It'll take 8 because we're saying that, well, it falls. But the relationship is not between 10 and 8. The relationship is between, we got the 10, it took 8 for the second unit. Well, the first two units, the first two units The 1 plus 1 and 2, would have taken 18 minutes, 10 plus 8. That's the total. And this total, if I find the average, will be 9. So this relationship is saying that as the cumulative output goes from 1 to 2, the cumulative average, the average here is 10 divided by 1, and that's 10. And the average here is 18 divided by 2, and that's 9. Right? It says this falls by a fixed percentage. It says this actually falls by, in this case, it's 90%. So 90% of 10 becomes 9. So Wright is actually saying there is a relationship, a clear relationship between output doubling and average time falling, and it falls by a fixed percentage. This is the key to this. So don't get, well, the key point is, if I know this, if I know that this falls by 90%, well, I take 90%, I get 9. Well, I can find the total time. I go 9 times 2, that gives me 18. I go 18 minus 10, and I can find how long it actually took to make the next unit. That's the skill here that you're trying to work on, right? So please focus a bit more on this. You can see I've almost done this whole lecture in this little slide here, but this is really, really key. From just sort of big numbers, we'll talk about the graph. I mean, ultimately, this is the graph. What we're saying is that the cumulate. I'm building this graph. I'm building the average time. This is what I'm saying. I'm building the average time. I'm saying the average falls with my cumulative units. So one unit will give me 10. 2 units, the average will be 9. The total will be 9 times 2. This is no different from a demand curve, if you remember when we did demand. And we're just arguing that it will fall as you keep going, right? But so far, this is what I can do. 1, 2, 4. Oh, my pen is gone. Oh yes, 1, 2, 4, 8, and I can sort of find that by, and I'm saying that this will fall by a fixed percentage. So 90% of the previous time, 90% of this is 88.1, if you like, and that will fall 8.1 minutes for 8.1 minutes for 4 on average. And I take 90% of this again, and that will give me something, and I can find that for 8, and that's what I'm doing here. Let's just finish off the slides so to see what's going on. Again, this is just what I just said, but again, you can see here it says average time. It's average. Yes, it's no different from a demand curve. Forgive me if I feel like I'm repeating myself. Average time and the cumulative production time, cumulative volume of production. That's the key point here. Yes, this is what I just said, and so, yeah, I mean, of course, the percentages, are different depending on how good the person is. But the key point is there is some learning effect, and the higher the learning effect, the better, right? Of course, it's to do with labor, so we're really focusing on the issues to do with labor, with people, and of course, with modern manufacturing, we're talking about very capital intensive, so machines would just do it for you anyway. Of course, the labor effect can't apply if machines are in the but and of course, if the product is new, it probably will. New products probably make it more probable. There'll be a learning effect. If it's complex, well, that's always going to be difficult. The learning effect will be much harder. So the more complex the product, the more likely the learning curve will be significant. So again, the key point is that for this to happen, for us to have a learning effect, it's like anything, that it must be repetitive. We must be doing it over and over again for us. But as you can imagine, at some point, this learning effect will cease, because, you can only get so fast at doing something. You just reach a sort of steady state of doing something. So it's about us doing questions to sort of see, just to really get to see what's going on. Like anything, if you start learning something and you stop, you go back again, you're probably going to go back again. So you might have something like, if you stop, you're going to kind of go back again before you have something again, just because, that's what happens when we take time out of doing a process. So, this is an example, the example I was talking about, for example. I'm interested in the average. This is the total. I'm not interested in total. I'm interested in average. This relationship is about this and this. That's what this is about, right? Okay, great. So I'll stop there, and in the next video I will look at, just like I said, because the issue really was, I can tell you using math what's going on with as we double, I can tell you this, but I can't tell you what's going on in between. I can't tell you what's happening at 3 without using a curve. without looking 5, 6. What happens if I want to find out what's happening at 5, 6, and 7? I can't do it doubling. So I need to look at either use a graph to actually work it out, or just look. We have an equation which we'll look at in the next video. But the first part was pretty much saying if you want to just double things, you can find out what's going on by using the learning curve rate. Okay, great stuff. Thank you. I'll see you in the next video.